Hello friends, so in the earlier video on lens we have seen how to draw the different ray diagrams for convex lens. So in this video I'll be discussing about how to draw ray diagrams related with concave lens. Quickly you'll see what are the standard rays we can use. We need minimum of 2 standard rays, so the 2 standard rays we are going to discuss here. So how to draw? You'll draw the principal axis, then you'll select one point, mark it as O, then draw a perpendicular, 3 lines on top, 3 lines below. Then from O at 3 cm F1, at 3 cm C1. From O this side again at 3 cm F2, at 3 cm C2. That is a standardized, or you can say a good standard measurement. You can take any measurement, but it should be equal. Whatever you take, distance from here to here, here to here, O2, F2, F2 to C2, all should be same. Okay, so after that you draw the lens. Make sure the lens is as thin as possible. So the first standard ray is any ray which comes parallel to the principal axis. After refraction, I discussed in my earlier videos that concave lens is a diverging lens, so it will diverge out. In which direction it will diverge out? So that when produced backward it seems to come from F1. Similarly, the second standard ray, we will draw everything. After that, if a ray is made to pass through O, it will pass without any kind of deviation. So these are the 2 standard rays that we can use. Next, so what are the ray diagrams we have? First is object at infinity. So when the object is at infinity, you know that we consider parallel rays to be coming in. So we draw the principal axis, mark O, draw the midline, draw the lens. From O we mark F1, C1 at 3 cm. So we take 2 parallel lines, 2 rays parallel to the principal axis coming in. Both will diverge out, so they will never meet. So in order to make them meet, we produce them backward. So both the rays seems to come from here. So the virtual image will be formed here. So what will be the properties of image? Position at F1, nature virtual and erect. Because the rays are actually not meeting, we are producing them backward to make them meet. So it is virtual, and virtual images are always erect. Size will be point size, because no matter how many rays you bring in, all will appear to meet at this point. So it will be a point sized or highly diminished image. Next, let us have a look at the other ray diagram. So this one is, I hope the page is visible to you. Let me adjust a bit. Okay, because we have quite a few things to be noted here. So the second position is object between infinity and optical center. Anywhere you can try keeping the object at C1, between F1 C1, at F1, or between F1 O. Wherever you keep the object, first ray will take is a parallel ray. It will diverge out. When produced backward, it will seem to come from here, and the second ray will make it pass through O. So both the rays, they appear to meet here. Why appear to meet? Because this ray is actually not coming here. So this ray appear to meet this ray at this point. So at this point the image will be formed. We mark this as A dash, B dash. So that will be the image. So properties of image: position between F1 and O, nature virtual and erect, and size will be diminished. So wherever you take the object, your image will be formed between F1 and O. Why? Because wherever you take, suppose I have taken the object here. From here I will make a ray pass through O. Fine. Another ray, if I take it parallelly, when produced backward, it will seem to come from here. So any ray will cut this particular ray between F1 and O. So the object image will be formed between F1 and O. Next we have the sign convention for lenses. So sign convention for lenses, because while doing numericals on lenses, you have to take positive and negative sign. I have explained it elaborately in my video dealing with sign convention on mirrors, so you can see that video. So things are basically same, only 2 things are different: the position of the real image. In mirror, what happened? The real images were formed in front of the mirror, and virtual image was formed behind the mirror. In case of lens, what happens? Real images are found on other side of the object, and virtual image, you can see it is formed on the same side as the object. That is the only thing which is different. So sign convention, we consider the two axes and we consider optical center to be at the origin. So whether it is your concave or convex lens, so the first surface is taken to be the main surface. So depending on that, we have the focal length. We take the positive or negative sign. So if it is a concave lens, so this is the first surface. So for this surface, the sphere will be this side. So f will be this side. Therefore, focal length is negative for concave. Same was with case of your concave mirror. F was negative. So it's same for lens and mirror. Focal length is positive for convex. So convex lens is the main first surface, this part of this sphere, and this sphere f will lie this side, which is same as that of convex mirror. So convex mirror also f was positive. Object distance u, we always take object on the left hand side, so object distance is always negative. Object height, we always take the object above the x axis. Object we always take this side, so on this axis the measurement will be positive. So object height is always positive. Image height is also same, just like mirror. Image, because virtual images are always found erect. Erect means above the x-axis, so it will be positive for virtual image. Image height h dash. And if it is for real inverted image, image height h dash will be negative. So more or less all these things are same for mirror. Now what is the difference between mirror and lens? So that is the image distance. Now you see, image distance v, that will be negative for virtual image, because in case of lens, virtual images are formed on this side. That means on this side of the x-axis, the values will be negative. So therefore, it is negative for virtual. But in case of mirror, what happened? Virtual mirror images were formed behind the mirror. So behind the mirror, therefore, the image distance was taken to be positive. But here it is negative image distance. And if it is for real images, image distance v, because real image, if I show you once. Okay, let's say this image you can see, real image is found on this side, so on this side it has a positive value. So image distance v will be positive for real images. So that's the sign convention we need to remember and follow. It's quite simple. If you remember the quadrant, the axis, you'll be able to, and the ray diagrams, if the ray diagrams are clear, it is very easy to remember the sign convention. Don't memorize. If you memorize, you are sure to make mistake in the exam. You will get mixed up. This will go there, that will come here. So try to understand the concept, try to create the picture. Any kind of studies, even for history also, if you are studying the battles of Panipat, you try to create some movies in your brain in relation to that whenever you read. So when you can create a movie in exam, you can easily recall. If you go to memorize, you are done. Okay, so we have, just like we had mirror formula, we have the lens formula. Format is the same, only symbol is different. Earlier we had, so lens formula 1 by f is equal to 1 by v minus 1 by u. And magnification for lens, m is equal to h dash by, sorry, it will be h dash by h, that means image height by object height. So this part is same as that of mirror, and this part in mirror it was minus v by u, in this case it is v by u for lens, v by u. So that is the only difference between mirror and lens. So in mirror it was plus 1 by u, here it is minus 1 by u. In mirror it was minus v by u, here it is plus v by u. Now meaning of magnification I have discussed in my earlier video also. Here I will just do a quick recap. If m is greater than 1, if m is greater than 1, then it means what? M is equal to h dash by h. So h dash by h is equal to, is greater than 1. So you should learn one thing for those who have confusion, just like we have, suppose x by y equal to 2. So I can keep the x here and I can take the y here, it will become y into 2. So same way, instead of equal to sign, if there is a greater sign or smaller sign, whatever, then also you can shift the variable. So x becomes greater than y into 2. So the same thing here. In place of m, I have written h dash by h, because m is equal to h dash by h. So m greater than 1 means h dash by h is greater than 1, which means if I take the h this side, so 1 into h is h, so h dash is greater than h. That means image height will be greater than object height. That means image is enlarged. M is less than 1 means h dash by h is less than 1. So I take the h this side, so h into 1 is h. So h dash becomes less than h. That means image is smaller than the object. That means image is diminished. M is equal to 1 means h dash by h is equal to 1. So I take the h this side, so h dash is equal to h. That means image is of the same size as object. So that is about the value of m. Now regarding sign of m, it's same as we have discussed earlier. So when m has a positive value, suppose m is plus 2, then plus means this is always positive. M means h dash by h. H is always positive. We know that from the sign convention. Now when the answer will be positive, when the above thing will be positive, above thing means the h dash object, image height. So image height is positive means where image height is positive, it is for virtual. So when m has a positive value, plus plus is plus, when m has a positive value, image is virtual. M having a negative value means h is always positive, we know. So in order to get a negative value, this has to be negative. H dash when it is negative, when it is real, h dash is negative for real. Say minus plus is minus, so image is real when the magnification has a negative value. Okay, so this interpretation is very, very important because it is required to understand and visualize more than usage in numericals. You need to visualize this thing. If someone tells you that an object is 2 times magnified, okay, then you should be able to understand what they are talking about. So another new thing that you need to learn out here is power of a lens. Now those of you who wear specs, you know that your specs, the lens of your specs has certain power. It may be minus 0.5, minus 2. So if you ask your friends also, you will find most of you, around 99% of you, or rather more than 99% of you have a minus value. Why? You will learn it in the next chapter when you will learn the defects of vision. But most of the children, you all have minus power. On the other hand, if you ask your parents if they are wearing specs, you'll find that their lens has a positive power. You can ask and see while you are watching the video, or after watching the video you can ask. Now why it happens, you see. Why it happens, why it happens you'll learn later, but how it happens, that is given here. So power of a lens. So what is power of a lens? Power of a lens can be defined as the converging or diverging capacity of a lens. On a practical note, if someone tells you iska chashme ka power bahut zyada hai, so if you have seen any of your friends whose specs power is very high, chashme ka power zyada hai, you will see that the lens is very thick lens. You can touch their spectacles and see they have a very thick kind of a lens, right? So lens is thicker. Why it is so? I'll be telling you. So overall, power of a lens can be defined as the converging or diverging capacity of a lens. More is the converging capacity, more is the power. So it is the reciprocal. Technically, what is power? It is the reciprocal of focal length. Reciprocal matlab ulta. So from here we'll know why some lens are mota and some are patla. Okay. So whatsoever, SI unit is diopter. P is equal to 1 by F, going by this definition, reciprocal of focal length. So when we use this formula, 1 by F means it will be in meter, and P is 100 by F. This formula we use when the focal length is measured in centimeter. Now you know that any kind of SI unit you have to define. So define 1 diopter, P is equal to 1 by F. So power becomes 1 diopter. What does it mean? When the focal length will be 1 meter. So we can write the statement power of a lens is defined as 1 diopter when the focal length is 1 meter. Okay. So power ka lens plus kab hota hai? 1 by F, when the F will be positive. Now when F was positive, you refer to the sign convention that we discussed little bit ago. So focal length, it is positive for convex lens. So if the power of the lens of your specs has a positive value, you will know that it is a convex lens. And since most of you have a negative power, when power will be negative? When the focal length will be negative. Focal length negative is for concave lens. So that means if your specs power is negative, you are wearing a concave lens. Now sometimes 2 or more lenses may be used in combination. So there's no problem at all. To find out the total power of the combination, PC, C stands for combination, you simply add the power of all the lenses with their symbol. There has to be the sign in front. Whether it is plus or minus, you have to put that and add. And so P means inverse of focal length. So focal length of the whole combination. Suppose these two lenses are in combination. So what will be the total focal length of this combination? Just make the reciprocal of the power of the combination 1 by PC, or you can add reciprocal addition of the individual focal length of the lenses. That can be done. तो अभी हम लोग एक प्रैक्टिकल चीज़ पे आते हैं कि मैंने कहा आपका फ्रेंड का अगर पावर ज़्यादा है लेंस का, आप पकड़ के देखिए वो लेंस काफ़ी मोटा दिखाई देता है. मोटा लेंस का मतलब है, हम लोग ये एग्जांपल से देखते हैं, ये डायग्राम से. लेट्स सी फ्रॉम दिस डायग्राम. सपोज देयर इज अ थिक लेंस. This will be required in the next chapter. That's why I am giving you little bit of idea. Suppose there is a thick lens, okay, and suppose there is a thin lens. So thick lens means what? Thick lens का मतलब है इसका curvature ज़्यादा है. So thick lens means it has more curvature. That means it is part of a smaller sphere. So thick lens means more power. You know that. Practically you know that. And this is thin lens. Thin lens means less power. So thick lens is part of a smaller sphere. So this is the center. Suppose there is O. So somewhere between will be F. So this will be the focal length. Okay. And this thin lens, it will have a lesser curvature. मतलब flat होगा ये lens. So ये flat lens, this is part of a bigger sphere. Okay. So this is the center. This is O. So F will be this much. This much is your F. So which F is more? This F is more. So less power matlab more is the focal length, and more power thick lens matlab shorter will be the or less focal length. So that is the inverse relation which is shown here. So ज़्यादा पावर मतलब छोटा फोकल लेंथ, और द लेंस का मोटाई जो होगा वो ज़्यादा होगा, और less power means longer is the focal length, patla lens, and so the lens will be thinner. So these are the overall ideas, some practical concepts and sign convention. So when you will do numericals for lenses, you will keep in mind the sign convention and the ray diagrams we have discussed. Thank you.